tools. When Ben told me he would be in Minneapolis, I was like, we can't pass up the opportunity to have him talk about this, since he's literally working on the tooling that a lot of us are starting to be interested in. So without further ado, give it up for Ben Kochie.
All right. Mic working? Excellent. So hi, I'm going to do a little talk about me. My name is Ben Kochie. I used to live in Minnesota. I grew up here, and then I got distracted and wandered off to California to work in Silicon Valley. I worked at Google for 8 years there, and then I got distracted again and wandered off to Germany and went from giant company with huge technology to tiny little startup with what the hell is going on? After spending 8 years at Google, I had become totally used to all the monitoring tools that we used at Google, and went back to a place where we used mostly open source stuff. And like, hey, when I worked at the university, we used Nagios. That was cool. I'm guessing we've moved on from that. Oh wait, no. What? People are still using Nagios? And a very good friend of mine who also is a former Minnesotan that I recruited to Google started a project called Prometheus. And so Prometheus is a metrics-based monitoring platform that was inspired by the internal tools at Google that they use for monitoring. And we'll first talk a little bit about what metrics-based monitoring is. So I categorize a lot of monitoring signals into two categories. There are black box signals and there are white box signals. Black box signals are things like pinging a website and like, does the web page respond? Well, that's one web page response, and the probe has no idea about any of the internals of the application. It only knows that the page responded, versus a white box metric, which is coming from inside the application, from inside the code, and it's I received an event, or I had an event inside my code, and I'm going to count that event. And that event can contain much more rich metadata about the event that happened, whether it's a black box ping coming in or an end user request. Now, the interesting thing is if you've got a Nagios check and you check every 5 minutes, and you're serving 1,000 requests per second on your website, what happens in that 5 minutes between black box checks? Well, thousands and thousands and thousands of requests happen between those two black box checks. And you could be serving 50% errors, and that one black box check comes by and it works. And you don't know that you're having an incident that should be going to your PagerDuty. So we found that we needed a white box-based, metrics-based monitoring system to replace Nagios, because we needed to be able to know that our site was up without actually having to probe it. So you have the old school black box probing things like Nagios and Isinga and Pingdom, and then you have new, whoops, slide error. You have new things like New Relic and Prometheus and InfluxDB. There are lots of good new tools for doing that have popped up in the last couple of years. So Prometheus is the project that I work on. So I work for GitLab, and GitLab pays me to build in instrumentation software into GitLab so that you'll be able to have an instrumentation console inside your GitLab development experience, so that you can use your production monitoring to feed back into your code's development. And that's something that we're working on this year. So Prometheus itself is a polling-based metrics collection. We wanted something that would be have more intelligence about our application, and not just did the probe succeed or fail. So we wanted to have metrics coming from the application, not just did I receive a request and how long it took, but did I go to the database? How long did the database request take? Did I have to go and make a sub call to another microservice, and did that succeed or fail? So we could find out from one application whether its communication with another application worked, and then we could also monitor that application and find out if its communications was working or not. So we'd have multiple points of visibility within the stack. that's also a slide. That's weird. That didn't render properly. Know what's going on. You want to know what's going on in the system, and not just is it there. The Prometheus client's design is very dumb. The client only needs to know about itself. It doesn't need to be taught about your monitoring system. So it's much easier for developers to develop their applications, and they only have to think about their application and what metrics they want to expose as developers. Here's a little obligatory diagram. The Prometheus server is a super simple, very robust single binary that sits in the middle of your network, and it connects out. So it has no external dependencies besides some local storage, networking, and access to your network. So there's no clustering to fail, because of course the first thing happens that when you have a network problem is all of your cluster-based systems fail. So Prometheus is not clustered. It's distributed, but it's independent distributed instances. Prometheus pulls, so it pulls all the data from all of your other sources. It can also pull metrics from a thing called a push gateway. So if you've got a cron job that lasts a couple of seconds and it just does a few things and it has an end result, it can push its information to the push gateway. Prometheus, because Prometheus is pulling, it needs to be taught about your network topology. So it needs to know where all your applications are. So we built a whole bunch of different service discovery mechanisms so that Prometheus can automatically discover your network. So it knows how to read from Kubernetes and Consul and DNS. And if you have other things like Chef or Puppet, you can simply create a Puppet template that writes, or a Chef template that writes out a list of targets that it needs to look for. And then it's the full retrieval, storage, and analytics engine. So you get all of this in one simple binary, and you don't have to create an Elasticsearch cluster just to get metrics. It's all in this one binary. It has a very simple web UI and an API so that more powerful systems like Grafana can pull in data from your Prometheus server or multiple Prometheus servers and other systems and combine them into a really great dashboard. Originally we built our own Grafana, and as soon as Grafana was out, we were like, oh, delete. Like, we're not front-end people, we're back-end engineers, we're site reliability engineers, we're DevOps people. We don't know how to do front-end. We're desperately trying to find more front-end people all the time. And then the next most powerful thing that Prometheus does is it allows you to take all your queries, anything that you can query, you can alert on. And this is where the alert manager comes in, and this is how you get from your metrics and all of your data to your incidents. And PagerDuty. A quick thing on the wire format. So Prometheus has its own custom wire format. We tried to use JSON. It was too damn slow. It chewed tons and tons of CPU time. So we went with this very simple text format that just basically is a line that contains the source of the data and the data. And it's just a simple key value pair of that data. But it's interesting because what you have is you have these metric names. The metric names come from some library, whether it's an HTTP request library or the CPU in your system. And this metric name defines a thing. And so this is the seconds the CPU spent in each mode. But on machines, there are generally more than one CPU, and there's more than one mode. So you count how much idle time you have, you count how much IO wait time you have, you count how much user space, CPU time you spend. And so you have all of these modes. And instead of, say, a graphite way of doing this, we built it with labels, so or tags, depending on your terminology perspective. We call them labels. Some people call them tags. But you can these labels identify the source of the data and the instance of the source of the data, and then we'll get into a little bit more of that later. But then you can query it, and this is what you end up with: is you use the Prometheus query language, which is I'm going to say, honestly, this is the hardest part of Prometheus. Setting up Prometheus is just dead simple. You have a config file, you have a binary, you have your exporters running on your machines. They're dumb. They just sit there. But getting the data out is a small learning curve that you have to overcome, because dealing with large amounts of vector data is a bit tricky. And there isn't really a common language for this. And people are like, well, why don't you use SQL? I'm like, SQL, I've got a really great example slide, but it doesn't fit in this short a talk, that talks about how SQL doesn't fit with vector data. When you want to do certain things in PromQL that are like, oh, well, I just want to chop and do this slice and dice, with SQL, you would have to have like I saw somebody who did this. He was doing metrics data in Google BigQuery, and he had like 20,000 lines of SQL to query on BigQuery, and I'm like, that's a one-liner in PromQL. Like, so it's a thing that it's one of the only technical hurdles that I see for Prometheus. So now let's actually get into metrics-based alerting. I'm an SRE at heart. I was a system engineer. I was sysadmin. So that's my background, and I follow a lot of philosophy on how to do site reliability engineering and DevOps and operations. And this is one of my favorite images from the Google SRE book, which is the system reliability hierarchy of needs. And monitoring is the most important thing that you have to have. If it's not monitored, it's not up, because you can't see it. If you don't have monitoring, you can't see it. So I find this metrics-based monitoring is really important. And so coming with this is metrics-based alerting is alert on the data, not just the checks, because you don't know what's going on in that 5-minute interval between one check and the next. You need to have event counters to be able to say for sure exactly how many errors happened in that 5-minute span. So you can poll every 5 minutes and get metrics every 5 minutes and know precisely how many errors happened. With Prometheus, things that you can graph, you can alert on. So if you've got a graph of how many errors per second you're serving, you say anything over this line is bad, page somebody. This also comes back into a couple of popular talks these days called the red method or the use method. They're sort of similar, two sides of the same coin. It's what is it? Now I can't remember the acronyms. Thought I had those written down. Oh yes. The red method talks about requests, because most of the things that we're dealing with these days as DevOps are web-based services, and you're handling user requests. So the rate, the number of requests that you're receiving, the number of errors, so how many errors how many things you've failed to do, or your application has failed to do, and the duration. So this combination of these three things, how long it took to respond to the user, is basically all the key indicators you need to determine if your service is healthy. Are you getting requests? Are they producing errors? And are they fast? The use method is a little bit similar. There's utilization is how busy is your service? Saturation, are you oversubscribed? And errors, and how many things have you actually failed to do? And it's kind of like two sides of the same coin. I prefer the red method terminology. Some people prefer the use method. They're basically the same thing. So we can actually get some real Prometheus examples. Now, of course, this would fall under the saturation or other metrics. And this is also exactly what we don't want to do normally, because who the hell cares if the disk is full? Nobody really cares if the disk is full. If the server is still serving requests. Just like this is not an incident, but it's like if it's under 1%, it's probably actionable. You might want to deal with that. And so you just take a PromQL expression, you assign an alert name, you give it a debounce for 15 minutes. Like this condition, the file system available space is less than 1% for 15 minutes. And we're going to mark that with a label so that we can use the alert manager to route the query to the next, or to the right person, or to the right severity. So if we want to make no disk space a sev2 incident, you can say critical on this alert, and then you can annotate it with some nice descriptions and including a runbook link. So you can automatically include a rendered URL to get the incident person or whoever's handling the page and handling the incident can actually go right to the documentation. We can do other fun things. Prometheus has some fairly simple analytics. Is we have a thing called predict linear, which basically does a linear regression filter. And so I take the last hour of disk space utilization and I project what that's going to be in 4 hours from now. And if that's if the available space is less than 0 4 hours from now, well, the disk is going to be full. And this is the kind of alerts that we want to do, because this gives me some runway that say that the disk will be completely full and the system will crash, but it gives me a 4-hour window of being able to fix that. So if the disk is filling up and filling up and filling up, the linear regression says, oh, we're going to be full soon, and you can fire an alert and actually get a message ahead of the problem. So you can be ahead of the thing. I like to, I talk to data center people and I say, you can do this with the temperature monitoring in your data center. So if you've got on-prem hardware, you can see the temperature rising if your air conditioner fails and get there in time to shut down the servers, or log in remotely and shut down some servers to fix the problem before your temperature is over your threshold and your servers are melting. Another good one is error rates. This is the E in the red method, and you can simply throw an error if there's more than one error per second, or whatever your threshold for errors are. You can also with the PromQL you can keep those label annotations, and you can actually have an error per service, and you can actually pass those labels get passed to the alert manager, so you can have one error query and one error definition in your alert config, and have all of your teams use the same error threshold and use the same alert, and the alert manager will just pass that service and as a label, and that'll fall through into the routing rules in the alert manager and get it to the right team to handle the incident. So it's really powerful. So you never have to update the alerting rules when simple things like the number of servers you have change or the number of services you have change. You don't. It's just less work to deal with. Unlike Nagios, where you have to, every time something changes, you have to update the config. With this, it's all the label value pairs just let you deal with the change happens automatically. And that's it. Now I can do some demo if anybody wants to see how some of this actually works in production. Yeah. How much time? My timer didn't work. Ah.
We're a little bit over the time we advertised people.
Okay.
So make sure they can keep socializing.
Okay. Well then, let's just go straight to questions.
Yeah. I feel
I'll
like
get two questions.
Yeah, they would love to see more. So I would say people are probably going to want to come up and look at it interactively.
But
sure.
Let's take a couple of questions if we have a couple. Ooh.
Hi, is it appropriate to use Prometheus to ingest SNMP metrics and use it as a replacement for MRTG or Cacti?
Oh yeah. So we actually, what we didn't have time to talk about is we have a whole we've already have a whole huge list of pre-built exporters and integrations. So we have a bridge called the SNMP exporter that can take your OIDs, translate them into Prometheus metrics, and then Prometheus will hit the SNMP exporter. The SNMP exporter speaks SNMP to your device, pulls all the data, transforms the OIDs into Prometheus style metrics, and just stores it. And so you can do that all you want. Yeah, socks motivated questions. Oh yeah.
So yeah,
sneaky. I've got GitLab socks for question.
Nagios. I always found like dependency management really hard. Just really any service monitoring tool. It seems. Could you maybe? I don't really have a direct question, but can you touch on service dependency management within Prometheus?
I guess I don't understand. Like what?
So like I have my ticketing server, I have my database server, and database server needs DNS and LDAP and et cetera and so on. And so I want to kind of like drill down so that I only care about my top level service.
We treat individual services. It's like in the Prometheus design idea, we kind of treat individual services as individual services. And if you monitor your DNS, you monitor your database, you monitor your app servers, you monitor your storage servers, that they're all kind of separate. And we don't really do any direct dependency management there, usually because these kind of things, at least from where Prometheus came from, they're handled by different teams. So the DNS alerts go to the team that's handling the network, and the database goes to this other team that does the database stuff. So there's not a lot of direct stuff there, but generally like because of the way Prometheus deals with alerts, unlike Nagios, you don't usually end up with pager storms. So the alert manager does a lot of deduplication and routing, so that you just don't end up with these pager storms that you would in a traditional Nagios setup. One more.
So related to that, does Prometheus handle like distributed tracing?
No, that's a separate thing. In Prometheus, we follow the do one job and do one job well Unix style philosophy. So we don't do tracing, we don't do logs, we just do metrics-based monitoring. We have a philosophy that some of these all-in-one tools do all of them badly.
Thanks.
I'm out of socks.
Too late for the socks. That's okay. I got plenty of good socks. Even Monotorama socks.
Ooh.
I know. Good stuff. Yeah, I'm curious. I mean, you were talking a little bit as an example about the 5-minute poll-based approach, and how that doesn't always work if it's like a synthetic monitor. So, you know, kind of what I wonder is, so how do you do like edge processing and push an alert back? Or maybe how does Prometheus monitor more frequently so that you catch something inside 15 seconds instead of 5 minutes later after it's fallen down and you've already lost $50,000 or whatever?
Yeah, so Prometheus polling intervals are completely flexibly configurable for every task, and they're all individually collectible. Like I have a thing that does, like we were talking about doing 1 second polling on our border router with over SNMP, so that we would have we'd have 1 second granularity on the border router, because the border router seemed to handle it just fine. So we just done 1 second granularity, and we could drill down to that level of detail if we wanted. Actually, I made a feature request to the config so that we could actually do sub-second polling if we really, really want it. Like it gets a little weird with Prometheus 2.0's buffering, but it in theory can work to sub-second polling.
So I want to know how well can you predict the future? Because I work at a big company, and like it'd be cool if we had like 6 hours ahead of time we knew based on 6 months of data. Like, what's the best case scenario you've ever seen Prometheus be able to accurately, correctly predict?
It's simple linear regression filtering. If you want to do fancier stuff, There is a Holt-Winters function, and some other people. There's a talk at PromCon about metrics from a data scientist perspective. So you can just pull data out of Prometheus and run whatever analytics you want on it. It has a time series database as part of the thing. We don't. We would love to have some data scientists actually add some real data science functionality to it, but yeah, if you have, it's not an analytics suite. We don't do anomaly detection. We leave that to external systems because that's more than you want in the thing that pages you that your network's on fire.
So it's just linear. There's no like standard deviation or anything. Okay.
Yeah. Well, there are functions for this, and there's several blog posts about this. And one more.
Okay, one more. If you can use the mic. Yeah, but it goes in the recording.
Why pulling and not pushing?
Why pulling? I missed that one in the slide. We pull because by pulling the application endpoints, because we're application focused, the real goal of Prometheus is to get metrics into every application. We want your application binaries, whether it's Java or Go or Ruby or whatever, to actually instrument themselves. We don't want to have to rely on exporters. So like I was talking to some Postgres database developers, like, hey, can you put an HTTP server in Postgres? They're like, oh yeah, we've already got one for this other plugin. Like, just have an HTTP endpoint in your Postgres database, and you just talk HTTP directly to Postgres and get the metrics right out of it. Because then you now get a synthetic black box check with every polling for free. You also there's also some timing things that are helpful when you're doing metrics correlation across many hundreds of instances. There's a little bit of math involved there that helps with this. Plus, when you're polling, the load on the system doesn't affect the load on the monitoring. So if you get a spike in user traffic, it's just a faster increase in the internal counter in your binary. It's not an increase of a whole bunch more UDP packets going out over statsd. And also with polling, the application can be dumb. You can just start up a binary anywhere in your production network, and it doesn't have to be told where the monitor is. So you can move your monitoring around, or you could have multiple monitors, or like you have a new version of Prometheus that you want to try, or a new Prometheus config you want to try. You just start up another one and pull the same targets, or a subset of the targets. It doesn't matter. It has some slight advantages over push for production.
All right, awesome. So we're going to call the questions there, but you can certainly come up and talk to Ben. But let's give it up for Ben.